So finally, let's now design a PCB. There are two parts to designing a PCB. First, you start with the schema. The schema is there to just make the connections between the components. When making a schema, you don't have to think about where the components should be positioned on your PCB. And by layout, I mean how everything is placed on your PCB. Because making the layout is actually the second part. There are many different software applications to make those PCBs. They are called EDAs. Some common EDAs are Eagle from Autodesk. It's free up to a limited sized board, but the free version may not be used commercially actually. Altium, this is an expensive one, mainly used in big companies. Fritzing, you may have seen the images of the circuits. Those are made with Fritzing. But Fritzing can also be used to make PCB layouts, mainly used by hobbyists. Easy ADA, this is an ADA provided by a site that also make PCBs and sells components. It's a fairly new one, and it is completely browser based. So you don't have to download anything or install anything for this to use. Which one you use is up to you. I don't have a preference yet. I used Eagle because most circuits on the internet are provided for Eagle, and it's free. Also, it has a nice integration with Fusion 360, which is the program I'm going to use to make the cases. But lately I'm using Easy ADA because it has a library manager built in, which has all the components they sell, and there's also a user section where you can share your PCBs, which is really handy for me to share stuff with you and build up a library with the components we use. However, there's no 3D model generate function yet in Easy ADA, but they are working on it. Other programs like Altium and Eagle does have this. For this course I will use Easy ADA, and to get started with it, go to easyada.com. Log in or register, go to project, make a new project, choose a name, and press create project. Now, first we're going to make the schema, so make a new schema. It will open in a new tab, and here you can make your schema. Left there are components, these are the most used components, and among them there's a resistor. If you click it and afterwards click it on the screen, you will see that it places a resistor on the screen. However, this is not how I want to do it. If you go to the shop and look for a resistor, you have more details about the resistor, and you will also know that the footprint is correct. At the left side you can go to the shop, click the button to go to the shop, and it will bring you to another site. Now, look for a resistor with as shape 1206, and the amount of resistance we want to be at 330 ohms. You can select any of those, all of them will be fine. If you press one, you can see a code here. Copy this code and go back to your Easy ADA screen. At the left there is a library manager, press that button. It will open a library manager menu, and at the top at the search bar, paste the code. You will get a 330 resistance resistor here, and place it on the screen. You may remove the other resistor. Do the same for the other components. For the LED for example. So look for an LED with the size 3528 and white. You will find one, press it, it will open the screen again, copy the code, go back and open the library manager. There will pop up one hit, select it and place it on the screen. Also don't forget to save. Ctrl S is saving. You can do this for each component we use in this setup. But I already looked up the components and you can just use the codes I give you here. They are also in the description. That mega chip seems to be very big, it's because it has so many pins. I also want to have a header on it so we can program it easily, but I want my header to be sideways like this. This doesn't exist in the library, as far as I know, so I made it myself, and you can use it. Just go to your library manager and look for a 2x3p side header. Go to the right to the user modules, and place it on the screen. So there's only one thing left to place, and that's the battery holder. Now we have to position it conveniently so we can attach everything. Just do what I do here. It doesn't have to be really precise. Now, we start to make the connections. Just make the connections as I do here. Actually, the connections are the same as the connections we made on the breadboard earlier. Really, you can just control it by looking at your breadboard and at this schema afterwards. When you have a connection with more than 2 wires crossing each other, you will see this red point. And when you cross wires with each other without them making connection with each other, then you will not see anything. Also, the schematic view is not representative for the reality. So you shouldn't look at the position of the pins, but at the names of the pins. You can open the pin out of your chip again, like we did earlier, and you can see the correlating names to the pins. So we use pin 3 for the LED, which is called PD3. So this is where we connect the resistor to. And this goes to the LED, and after that to the ground. Don't forget to save. Now only the pin headers are left, which we will use to program the chip. You can rebuild it just by looking at your already made breadboard, or look at the schema actually, which you can find on the Git of the mini core we downloaded earlier. But in your case, you can just copy it from me. Make sure the 1 is connected to the ground, so you can easily recognize which pin is the ground. Don't forget to save once in a while. And you're all done. The fun thing is that we used all parts of the store. An advantage of this is that we can easily make a BOM, which stands for Bill of Materials. There you can see which components are used and how many and the price of each component. But it is not useful for us now because we already have our components.